So today I'm going to be looking at unRaid right now, and I'm going to be going first of all through what I'd say the pros and cons are, and then I'm going to be running a few tests to see how it handles different edge cases and drive failure situations. I'm going to mainly be looking at the storage system, but I'll do a quick look at VMs and other solutions. So here's the hardware I'm going to be using for this video and probably all the upcoming ones on different NAS OSs. I have a Core 2 Quad Q9450, 3.5 gigs of DDR2, mismatched drives ranging from 3 terabytes to 200 gigabytes just to test mismatched drive speeds and sizes. I can get a full array of 1 terabyte drives if I need to test identical drives as well. Moving over here, it's already been booted, and I have a USB drive it's booting off of. And the first menu you get is your boot menu that's using a standard Linux boot menu. You have standard unRaid, which is what it'll boot to by default. GUI mode, which I'll take a look at right now. Safe mode and GUI safe mode. So let's boot into GUI mode here. It boots pretty quickly. One thing to note from unRaid is it boots into rootfs. That's what it uses, which basically what it does is it copies all the drives in the flash drive into RAM, which is roughly 150, 100 some megs. It's a very lightweight OS. And then it runs everything from RAM, which keeps writes on the USB drive to a minimum because most USB drives are using very cheap flash. And the disadvantage of that is it's a USB boot system only. And now we're booted, this is running the latest version. You get a username and login prompt, not the prettiest thing, but it works fine. I'm using root with no password, which is its default. I wish it would require you a password just for extra security. And now we are booted. I'm going to zoom in so you can view it a bit better. So you get the standard menus. You get to pick what all your drive sizes are. I don't have any other drives now. One thing to note is it won't start anything by default on boot up, or at least it doesn't seem like there's an easy way to. By default, you have to manually click Start Array. So if you want to shut this down every night, it's going to be pretty annoying, or you're going to have to script it in there. And yeah, you can start a standard terminal. It's a full-featured Linux OS. You can run all Linux features. And it's working, and it seems like most of the time you just reload the page to get the updates, and it should have started. And let's first take a look at what I've listed out as my main pros and cons with the DIT drive setup. So the main pro I'd say, first thing is real-time data redundancy is a huge thing, so it always writes data to the parity and the drives at the same time. Assuming you have a parity, or if you have RAID 1 for cache, you will always have multiple copies and redundancy of files, so you never have to worry about file loss due to a single drive failure. Next thing is you have flexibility. You can easily mix and match drive sizes in the future, which is great for a home server, which is basically what this is built for. Next thing it has is you can easily get data from one drive, so I can pull out one drive. I'll still get data no matter what else happens to the system. It's standard Linux formatting of drives. You have to hunt through a few folders, especially if you have multiple drives, you have to merge it together, but it's still really easy to get it, where other RAIDs, if you lose more than the max redundancy level, you've lost everything, and there's basically no way to get any data back. And easy write caching is setting up, but easy write caching gets us kind of into the cons, which is it's slow. Due to how it has to manage writes on the parity and one drive, yeah, it's going to be pretty slow doing that. But that does give us one more pro, which is its low power, because it only has to spin up the drives it needs to. You can have a fast write mode, which will write to all the drives at the same time, and use all the other drives for the parity data. But the disadvantage is now you're spinning up drives, and if you have a large server of 20 plus drives, that could easily be over 100 watts of drive spinning power. Other problems. No bitrot protection. It can use BTRFS for data volumes, but they're not using the checksumming in there. And to my knowledge, there's no checksumming protection of files at all. But we will do some testing with bitrot protection in the future and see how it handles it. Other disadvantage is no file system compression, but for a home server where most of the time you're storing compressed files anyways, like videos or photos, really won't make a difference. Looking at the system advantages, big ones I'd say are stuff like it's fairly easy to use. It's a pretty darn easy to use interface. You don't really have to dig into the terminal unless you want to, which you definitely can do, but you don't have to. We got the other advantages, which is easy to use Docker and VM support. I give it pretty much some of the best support for VMs and easy to use VM support. It's not a great hypervisor if that's your goal. Something like Proxmox is a lot better of a hypervisor because there's no clustering. There's a lot less features that more advanced hypervisors have. But it is a perfectly good for most home users if you just want to fire up a VM and run something in it, which we're doing a little bit. Next disadvantage is cost. It's not a free OS. Technically, you could get it for free if you really wanted to, because it is open source and you can compile it, but to my knowledge, no one's been doing that. And really, it's not that expensive. Support the developers for good software. So let's take a look at performance right now. So this is a basic graph we've made up with the first two columns on the left being sequential read and sequential write. So the very left blue one is an unRaid array, the next orange one is an unRaid array with a cache, the yellow one is just a single bare drive, I think it was a 2 terabyte Hitachi 7200 RPM, and the next one was a basic file server over NFS that I set up just using exploits in Linux, and the last one is just Windows Home Server 2003 for comparison. Now we can see there's quite a huge improvement going here. Now one thing to note is the read speeds are on the cache drive, so I haven't made it sync it back for that, but without the cache, this is pretty slow, and I was trying to find out exactly why, because it shouldn't be that slow. As you can see, I can easily get higher speeds with other systems, but it seems to be due to CPU limitations. I might try this later in the future with a faster CPU, but the cache drive does circumvent this because it doesn't have to calculate parity real time. So, and the other devices on the other smaller random reads are much slower. So let's zoom in on the random reads and writes. So here we are zoomed in on the random reads and writes, and we can see the performance is pretty poor. I haven't put anything in for reference, but a standard HDD is about the same as an unRaid with cache. The network really isn't slowing it down very much, but the unRaid array is a good amount slower in random reads and writes than a standard one. I did get one oddball result here, which is with the cache getting significantly higher speeds on this is a random read test. But my guess is that's due to some anomaly. I had to do some testing to try to circumvent the effects of caching, which all of these OSes do, by using really large files that couldn't be cached in RAM. Overall, the performance of unRaid with a cache drive was perfectly fine for a home server, though without a cache drive it does feel a bit slow, but we'll look at more solutions in the future to see if other ones are actually significantly better. But as a archival media solution where you just put movies onto and play movies off of or copy old files and backups, it will work perfectly fine. So now let's try looking at some failure modes after we've seen the performance. So due to its different RAID setup, I don't know exactly how it's going to handle drive failure. So right now we're doing copying of files to it, of which according to the writes thing, they're mainly going to the fourth disk, which is my 1 terabyte drive. So right now I'm just going to go and unplug it and simulate a disk failure. And it looks like it stops for a second, but it should restart according to my testing. I don't know where it's going to put the files though. And it isn't. Okay, so let's reload this page here. And it's going to say it's missing like I thought it would. And all the writes have turned into errors as it's trying to put files on it but can't. And it's shooting back up, so now it is copying files again. So we did have a couple of seconds of downtime. So if you need this for running a large database on your website, don't use it. But that's not the intended use case. If you're copying files from your desktop having backups, you don't notice the failure at all. So I got another one of those drives that we can try doing a quick recovery of. So we're going to cancel this file transfer here. And we're going to try replacing it. So I've got another hard drive here I'm about to replace it with. It's the exact same model and type. The only annoying thing with unRaid is there's no way to replace drives hot. So that means you do have to take it offline to replace drives. But for a normal home server where uptime is not the most important thing, that's not a huge problem. So if I take it offline, it'll take a couple seconds for it to unmount everything. And then I'll reload. And it should change this view here to the one that shows me the configurable drives and not just the currently running drives. So now my drive's been added. I don't need to reboot it. Some tests, some online guides say you should do it, but you don't have to. So now if I hit, start, it will start parity sync and or data rebuild as it tells you. So you have to click a confirmation. It'll take a couple seconds and reload the page. And then it should start doing parity sync and copying all the data back. And this will take a little bit, but when it's doing it, if I CD onto the drive, it should all be visible. And to my knowledge, there's been no change. I mean, that's all my files, so they're all still there, so that's fine. And if I go back up right now, it says this drive contents are emulated on the parity, which is pretty much what you'd want. All the data is still there, and it will be writing a lot of data onto it from the parity drive. So it does handle single drive failure perfectly fine. So let's get into a little bit more testing. So first thing we're going to do is testing adding a drive. So I have another 1 terabyte WD drive right here. We're going to just add it to the array and see how it handles it. I just plugged in the 2 terabyte. And it doesn't allow you to do adding or removal of drives, so you're going to have to stop it. And this means nothing can use the array. So any plugins or VMs that are using that array are basically off right now. So now we've had a drive added. So if we go under disks, you can do it all hot. They don't tell you can do it hot, but it does a full hot adding and removal of drive support. So I can add the 1 terabyte here, and it's going to think about it. It's going to say all data is going to be erased, and we're going to click start. And yes, it will be erased, and it'll take a little bit. Now, I think by default it'll do a pre-clear, which essentially is DDing 0 on the whole drive. Is it necessarily needed? No. You only need to write the partition header, but they're using it. It is a good way for the drive to force it to remap any sectors and find out if there's problems, which isn't a horrible idea for what they're doing. So, and now it's going to take a few seconds, and you do have to reload the page. It doesn't do auto-refreshing. But here we go. We're in. And we can see it's doing a pre-clearing of the drive, which basically means it's zeroing it. Which will, I don't know if cancel will force us to not use the drive, but we're going to let it pre-clear, and this will take many hours. And then now we can click start, and it will melt the disks. Let's take a quick look at what's happening under the hood. So I don't know exactly how it's working, and there's an easy explanation out there, which is basically you have drives with data and file systems on it, and it makes a parity. But let's get a little bit deeper and see how they're actually running it. So LSBOK will show us all the logical devices on here. So we see the USB drive, which appears to be SDE, which only has one partition on it. It's FAT32 and it's mounted in /boot. So let's look at looking up here, we have DFS-H, which shows us where all the mounted ones are, and we can see / is mounted on rootfs. They seem to be using a lot of slightly different ways than you normally do in Linux here. Rootfs is a way of having a root file system on RAM, so root's completely on RAM. I think it's based off of TMPFS. It's a RAM disk solution, which lets it so that if you use more space, it uses more RAM. If you use less space, it uses less RAM. So it only uses as much as it needs. And that's actually running off of basically what you do is when you boot it, it copies the files to RAM, and then it doesn't touch anything. And I think you can have it so if it changes config files and stuff, it'll go back and edit the original drive. I don't use this too much, so I'm just using a little bit of info I've seen. So the next thing is the data drive. So like SDF's the data drive with a 1.8 terabyte volume. So the other thing I've been curious is that how is it formatted? So they all have one partition. So if we look at how much it's formatted, one way to find out is to go like gdisk /dev/sdf. And that will show us that it's a MBR only. So that's MBR only, SDF. So I do have a drive bigger than 2 terabytes, and it's SDA. So if I look at this drive, SDA, it will show us that it has a GPT. So that's another interesting thing we notice. It seems to be smart enough to use GPT on any drive over 2 terabytes automatically. Uses MBR for smaller drives, which I personally say is a bad idea. I'm personally big, just run GPT on everything, but that's their decision. So we also see another device, a loop device. A loop device basically in Linux lets you use a file as a partition, and they're using it for the etc libvirt file. So this is configuration for virtualization on here. And then we get these MD devices, and I'm assuming these are being pulled off because they're the same size as your drives. These are being pulled off and mounted, and my guess is they're using MD under the hood to manage the parity. Now the other devices, you notice you don't see here any of the big drives that it's actually using as part of the array. So if we go back to df-h, we notice this SHSFS, which is a SSHFS, which is a fairly small project that's been around for a while, and lets you have a mounted file system over SSH, which is weird because it's all on one system, and I don't know exactly why they're doing it. So seems to be running it's running /run/user, and it's running as a fuse process. I don't know exactly why they're doing that. That seems really interesting to me. But that's basically what they're doing. They're running this a little bit older now. My guess is they haven't really touched exactly how this under the hood code runs since the old versions of unRaid. They've changed a few file systems and stuff on the upper end and added virtualization, but I'm guessing we're gonna use MD for the parity. They've added, I don't know exactly what they're doing because they're using XOR for the first ones, and then I think they're using Salmon or Reed-Salmon for the second parity drive, because you can only do one drive with XOR. and they're using SHFS for the mount, which it seems like a small project they picked a while ago, and apparently it's working fine. And it looks like they're probably just using it to stack all the different ones. Now we can also go cat/etc/fstab. It is annoying. Fstab shows us where all the boot devices by default are, and you see there's pretty much nothing. It just mounts this in /boot. So they aren't doing anything in fstab, and it must all be scripted in here. And I'm not going to look too much into this, and you can tell it's a very modified OS. It's based off Slackware, but they've changed quite a bit of stuff under the hood. So it's definitely not, it's not a great Linux distro if your goal is to have a Linux distro to play with the command line. You can use the command line to get some data, but if your goal is to play in the command line, don't go. But I just thought it'd be interesting looking at kind of how they're doing it under the hood here. And this is the most I can kind of get quickly without digging too hard into the source code or digging too much into exactly what's happening under the hood and analyzing it. So thanks for watching this little review of unRaid, and I plan on doing more NAS OSs in the future. Looking forward to doing FreeNAS and box stores soon.